All right, so like I said, I'm recording this lesson to put it on the internet on Haiku. The homework is on page 605, 5 through 10, 22 through 27, and 29 through 40. And that would be all of each one of those, okay, y'all? So today we're going to talk about vectors. And you'll use vectors in physics when you get there next year. But, a vector is a ray that has magnitude and direction. Magnitude is a fancy word for length, and direction, of course, is which direction it's going. So a vector can be represented by two letters, A, B, with a vector symbol over the top, which looks like that, or half of an arrow, or it can be represented by a little letter with an arrow over the top of it. If it's represented by two letters, A and B, the first letter is the initial point or the beginning point. Let me put it over here. The beginning point where it begins, and B is the direction it's going in. Okay? So A is the beginning point and B is the direction it's going in. A would be called the initial point. And like I said, in the direction you're going. The terminal point is where it ends. So in this case, B would be the terminal point. So A would be the initial point, B would be the terminal point. The next word I have up here is called a resultant. It's the sum of two or more vectors. So when we say array, a vector is in standard position. That means its initial point is at the origin. So the initial point is at the origin. So in this case, ray AB, the initial point is at the origin. If it is in standard position, then it can be described by its terminal point, which in this case is 3, 5. When we talk about a vector in standard position, which this one is 3, 5, we have these little vector symbols around it. So like I said, a vector is a ray that has magnitude and direction. Magnitude is the length. And if we wanted to represent the magnitude, we would have, they look like absolute value symbols, but they're really not, with the A, B, and the vector symbol over it. To find the magnitude, of a vector, we're going to use the distance formula. So in this case, we had A at 0, 0, and we had B at 3 and 5. So that finds the length of the vector. So if this is x1, y1, x sub 2, y sub 2. So we have 3 minus 0, and then 5 minus 0. So we get the length of this at 9 plus 25, or the square root of 34. Just leave it as the square root of 34, y'all. Okay, I don't need to have a decimal. So now let's talk about direction. To find the direction of a vector, we're going to use the tangent ratio to find the measure of the angle that the vector forms with the positive x-axis or with any horizontal line. So the tangent of theta is going to be the opposite over the adjacent, but all we need to remember is it's going to be the y value over the x value if it's in what we call component form. So in this case, the vector was in standard position, and we got the origin at A and the ending point at 3, 5. So we're going to use those points 3 and 5. This is the x value, this is the y value, so the tangent of theta is equal to 5 over 3. We put that in our calculator, we would go second tangent, 5 over 3, and get that the direction is 59 degrees. Okay? All right. In order to find the magnitude and the direction, but specifically the direction, your vector needs to be in component form. So component form means it has these little brackets around it. So that means that your vector's in component form. Well, let's talk about how we're going to put the vector in component form. To write it in component form, we want x sub 2 minus x sub 1, y sub 2 minus y sub 1. So that puts it in vector form, where x sub 1 is the initial point, x sub 1, y sub 1 is the initial point, and x sub 2, y sub 2 is the terminal point. Now that's important. This part's really important. You got to get them in the right order or you won't get the right numbers. So component form. Okay, so all right, so on one of those graphs that I gave you, let's do this. And I'm going to leave this one up here and just draw myself a picture over here. you know that a graph has 4 quadrants, right? All right, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I've labeled this quadrant 1, 2, 3, and 4 at the bottom. Okay. Okay, so the next thing I want to remind you all of, which you would have done this in Algebra 1, is that if you're in quadrant 1, both your x and your y is positive. If you're in quadrant 2, your x value is negative, your y value is positive. So, because you're on the negative side of the x-axis. In quadrant 3, you're at negative, negative. Both the x coordinate and the y coordinates are negative. Then in quadrant 4, you're at the positive x, negative y. Okay. Okay, so how many degrees in a circle? Does anybody know this? We haven't talked about circles yet. There's 360 degrees in a circle. So if you started right here and walked all the way around, you go 360 degrees. Okay? If you went half of the circle, you go 180 degrees. If you went a fourth of a circle, you go 90 degrees. If you went 3/4 of a circle, you go 270 degrees. So I have that on my graph over here. Okay. All right. So now let's talk about a little bit more, because you'll have to do this in physics. I don't know if we have any word problems that have to do with this, but we might. Okay, so let's talk about north, south, east, and west. Okay, this would be north. This would be south. This is east. And this is west. All right. So let's go back to the direction. And I'm going to draw this picture again over here. So if your vector looks like this, and you're in quadrant 1, then the tangent of theta, which is its direction, is going to be equal to y over x. Whatever answer you get for that is the answer. So that's the answer. Put that on your paper, y'all. In quadrant 1, tangent of theta is equal to y over x. In quadrant 2, it's going to be 180 degrees plus your answer. In quadrant 3, it's going to be 180 degrees plus your answer. And that's plus answer. All right. And in quadrant 4, it's going to be 360 degrees plus your answer. Y'all will understand in a few minutes, okay? All right. Does everybody have all of those on their little picture? All right. Next, I want to talk about operations of vectors. Alright, so as long as your vectors are in component form, this being component form, you can add or subtract them or have what we call scalar multiplication. So for addition, you're just adding the A to C and you're adding B to D. And that's your new vector. That's not hard, is it? Subtraction's the same thing. You're just subtracting A minus C, and you're subtracting B minus D. When we talk about a scalar is a real number. So what we're doing is we're multiplying this vector times k, which is the scalar. So we get k times A and then k times B. Say that again?
Can you stay on this?
Mm-hmm. Y'all ready? All right, so I'm starting with my first, you got your worksheet and all? We're starting with vector A. Okay, so everybody has that one? All right. I don't know that you have graphs, but so the first thing we're going to do is find the magnitude. Okay, so the magnitude is represented, like I said, by, it looks like absolute value symbols. So the magnitude, if it is in vector form, all we have to do is take -2 and square it, and 4 and square it. We don't need to plug it in the distance formula, or we really are plugging in the distance formula, but we don't need 2 points because it's in component form. So if we put this in our and you don't need a calculator. If you have one, that's fine. This gives me 4 plus 16. So we have that the magnitude is the square root of 20, which is 2 square roots of 5. So that's the magnitude. Anybody have a question about that? Okay, so then let's put this over here. Move this somewhere else. All right, so if you graph this, you're at -2 and 4, and you're starting at the origin, so you're going like that. Okay, so there's your vector, -2 and 4, because this point is -2, 4. Okay, everybody? All right, so now we want to talk about the direction it's going in. All right, so the direction is always the tangent of theta, which is going to be the y value over the x value. So we get the tangent of theta is equal to -2. So we want to put this in our calculator. and find out what the degree is. So once again, you want to make sure that the degree is your calculator's on degrees. So we're going to say second tangent and put in this case, -2. So what we get is 63.434. So we're just going to leave that at -63.4 degrees. Okay. All right. But that's not the answer. That's not the answer because we're not in quadrant 1. We're in quadrant 2. So we want to find how far it is from here to here. So the actual answer to this is 180 degrees plus -63.4. Okay. So if we put that in our calculator, what do we get? We get 180 degrees minus 63.4. And we get it's 116.6. And what that means is that if you start here and walk all the way over here, you've gone 116 degrees. Okay? Everybody? All right. So this is the magnitude. This is the direction. All right, so what quadrant are we in on the second example? Say that again. Quadrant 1. That's right. We're in quadrant 1. So in quadrant 1, we don't have to worry about adding or adding 180 or 360, do we? All right, so the first thing we're going to find, like I said, is the magnitude, which is the absolute value of B. So we're going to say 3 squared plus 5 squared, which is we did a few minutes ago, and we get 9 plus 25, or the square root of 34. So that's the length. The direction is the tangent of theta is equal to the y value over the x value. The second tangent, 5 divided by 3. we get 59 degrees. Because we are in quadrant 1 at 3 and 5, okay? 59 degrees is the answer.
In the last one, we divided like 4 and -2, so would you not divide 5 and 3?
Well, you can, but just because it was a whole number, I divided it.
Okay.
We could have just put it in the calculator. Everybody good with this one? Ready? Now y'all ready? All right. So now we got 3 and 4. All right, first we're getting the direction. No, sorry. Magnitude. Let's stay consistent. Magnitude. So when we square these and add them together, we get the square root of 25, so the magnitude is 5. So that would be the length of a vector. As far as the direction is concerned, once again, it's the y value over the x value, so the tangent of theta would be equal to -4 divided by -3. So we have second tangent, -4 divided by -3 is just 4 divided by 3. Oh. Okay, so we got 53.13. So let's talk about that. What quadrant are we in, y'all? The third quadrant. So we're in this quadrant over here. Okay. So because we're in the third quadrant, we're going to say 180 degrees plus 53.1. And when we do, what do we get? 233 degrees. So we have to add the 180 to it because this is how far we went. Everybody good? All right. Are there 2 on here, y'all? All right. I'm going to let y'all do numbers 5 and 6 by yourself.
What do you not do 4?
The first thing you're going to find is the magnitude, and the second thing you're going to find is the direction. So first find the magnitude, then find the
Can I
direction.
have your attention, please? I'm sorry for the interruption. I need all junior and senior track team members to please move your cars to the sophomore parking lot. Thank you.
So the magnitude of vector E would be the square root of 2 squared plus negative 7 squared. So hopefully you got 4 plus 49. So did you get the square root of 53? And the direction would be the tangent of theta would be equal to negative 7 over 2. So second tangent, negative 7 divided by 2, and we get negative 74.05. Okay, so what quadrant are we in? We're in the 4th quadrant, right? So we're going to add this to 360 degrees. So 360 degrees plus negative 74 point, we'll make it 1. So we're adding it to 360. Guys, I don't know what the problem is. So did y'all get a direction of 285? Okay. All right, how about the second one? Have y'all done it? Give you a minute to do that. So the magnitude would be equal to the square root of negative 6 squared plus negative 1 squared. So we get 36 plus 1, or the square root of 37. Everybody good on that one? All right. So then the direction is the tangent of theta is equal to negative 1 divided by negative 6. So we have second tangent Negative 1 divided by negative 6 is 1 over 6. But what quadrant are we in, y'all?
The third one.
The third quadrant. So we're going to add 180 plus 9.5 to get 189.5 degrees. So that would be 189.5 degrees. Everybody understand that? Everybody good? All right, so I'm going down to number 7, 8, and 9. Maybe. All right. What do you notice about 7 and 8? These are not vectors, are they? This has a parenthesis and a parenthesis. That has a parenthesis and a parenthesis. So those are not in standard form. Okay? So, we have to use the component form to put them in standard form. So, remember the component form was x1 minus x sub 2 and y sub 1 minus y sub 2. So if we label this x1, y1, x sub 2, y sub 2, the order that we do this in is important, y'all, because it has to be the initial or the beginning point first and the ending point second. So we're going to say 3 minus 6 and negative 4 minus 10. So we get negative 3 and negative 14. So let's talk about what's happening here. We got the point 3 and negative 4. That was C. And we have 6 and 10. We got something that looks like that. So what we're doing is we're moving it so that it would be in standard form. Okay? I bet I messed that up. Let me look at something. I did mess it up. Alright, let's start this over, y'all. I messed it up. It's got to be x sub 2 minus x sub 1. That's my fault. Alright, so let's start this one over. I messed it up. Alright. So we're going to get x sub 2 minus x sub 1, and then y sub 2 minus y sub 1. I thought that was wrong. Alright. So, x sub 1, y sub 1, x sub 2, y sub 2. So the ending point comes first, and the beginning point comes second. Okay, y'all, so we get 3 and 14 for our new position. Alright, so I've drawn the first one. Let me go back to draw the picture again. So we got 3 and negative 4. And we got 6 and 10. Okay. Alright, so what happens is when it gets put in component form, it moves it so the initial point is at the origin, and the ending point is at 3 and 14. So we would be over 3 and up to 14, which is about there. So we'd have something that looked like that. Okay, so the length of it's not going to change, it's just going to be moved. Okay, so the magnitude would be the square root of 3 squared plus 14 squared. So that's 9 plus 14 squared, I think, is 196. Somebody put it in their calculator. So we get 205. All right. So the direction would be the tangent of theta would be equal to, so we have to use the component form, so we're going to say 14 over 3. All right, are we in the first quadrant? Yes. So we have second tangent 14 divided by 3. And so we know that that is 77.9 degrees. So if we went from here to here, we'd have gone 77.9 degrees. Okay? Yes. Okay, so when y'all are doing these that you have to put in component form, y'all write down the formula so that you'll remember it and don't be like me. So it's x sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay, so x sub 1, y sub 1, x sub 2, y sub 2. So we have 2 minus 6 and 3 minus 7. So we get negative 4 and negative 4. So what quadrant are we in? The third quadrant? So the magnitude of AB would be equal to 4 squared plus 4 squared, which would be the square root of 32. The tangent of theta is equal to negative 4 divided by negative 4, which of course is equal to 1. So the answer is going to be 45 degrees, but we'll put it in our calculator. So the tangent, second tangent of 1 equal 45 degrees. Okay. But what quadrant are we in, y'all? We're in the third quadrant. So we're going to say 180 degrees plus 45. So we're at 225 degrees. All right. So next year y'all gonna have to do this in physics, so y'all will have already done a lot of this, and so hopefully next year won't be so hard. Usually they get to it in physics before I get to it. So that takes me to the next set of problems. We've already done those. We haven't done 9 and 10, have we, y'all? Huh? I don't think so. Alright, so once again, they're not in component form. In component form, the beginning point would be at the origin, and in this case it's not. So x1, y1, x sub 2, y sub 2. So the beginning point is the initial point, and it needs to be x1, y1. So we're going to say 3 minus a minus 2, and negative 3 minus 2. So we get 5 and negative 5. Okay. So what that means is if you drew the new would be over at 5 down to negative 5. So it would be 5 and negative 5. Is that right? So we have something that looked like that. Alright, so let's find the magnitude. The magnitude would be the square root of 5 squared plus negative 5 squared, which would be the square root of 50. Okay. Then the tangent would be equal to negative 5 over 5. The tangent of theta would be negative 1. The second tangent, negative 1. It's going to be 45 degrees again. No, it's not. Oh, I'm out. Second tangent, negative 1. That's negative 45 degrees. Alright, but what quadrant are we in, y'all? We got 5 and negative 5, so what quadrant are we in? And then where's the picture? We're in quadrant 4, so we're going to say 360 degrees plus negative 45, so we get 315 degrees. Okay, y'all want to do the next one on your own? Let's see if y'all can get this one. Alright, so if this is the initial point, we're label it x1, y1, and the ending point x sub 2, y sub 2. So the component form would be 4 minus a minus 2 and 5 minus a minus 3. So we would have 6 and 8. So to find the magnitude, we'd say the square root of 6 squared plus 8 squared is equal to the square root of 36 plus 64. So we have the square root of 100, which of course is 10. So then if we're looking for the tangent of theta, which gives us the direction, we have 8 over 6. So second tangent, 8 divided by 6, and we get 53.1. All right, we're in quadrant 1 because that's 6 and 8. So that is the answer. So it's 53.1 degrees. So I'd like to jump down to numbers 13 and 14. And 16. All right, so on these they're asking you to add vectors C and A. On the first one, so C is 6 and 7, and A is -5 and 2. So y'all, this is not hard. We're just adding the ones that are in the like positions. So we're adding these together. So we get 6 plus -5, and we get 7 plus 2. So what's our new vector? So our new vector would be 1 and 9. This is what we call a resultant. Okay, that's a 9, not an A, y'all. Alright, so let's look at the next problem. On the next problem, you're multiplying vector B by 2. So we're multiplying this vector by 2. And then we're adding A to it. You've got to multiply the first vector by 2 first. So we get -4, -8 before you add the second vector to it. So we have -4 plus -5 and -8 plus 2. So we get -9 and -6. All right, everybody okay with that? All right, see if y'all can do number 16. See if y'all can do number 16, y'all. Jordan. So like I said before, you got to multiply by the scalar first. So negative 3 times 6 is negative 18, and negative 3 times 7 is negative 21. We're subtracting vector b, so that's negative 18 minus a minus makes it plus, and negative 21 minus a minus makes that plus. So we get negative 16 and negative 17. How'd y'all do? So going back, the homework is on page 605, 5 through 10, 22 through 27, 29 through 40. So let's get those done. If you have a few minutes, you probably could get some of them started. If you have trouble with this, go back and watch the video.
Sometimes I still find my mind in bed.